Welcome to EDU World Space.
So we are given the de Broglie wavelength of an electron, and the first part of the question is to find the momentum. So we will use equation 27(8). So according to this equation, momentum is equal to Planck constant over lambda. So this is equal to 6.63 times 10 to the power minus 34 joules second over 4.5 into 10 to the power minus 10 meter. And this gives the momentum to be 1.5 into 10 to the power minus 24 kg meter per second. Now in the second part, we have to find the velocity of the electron. So here we are assuming that the electron is non-relativistic. So we will use equation 27.8 again. So P is equal to H over lambda. And okay, so maybe we don't need to use, now that we have assumed that this is non-relativistic, we can simply write the momentum P is equal to mass times velocity. So velocity will be equal to then momentum over the mass. And we have already calculated the momentum here. So we will use that in this equation. And mass of the electron is 9.11 times 10 to the power minus 31 kg. So we get the velocity to be around 1.6 times 10 to the power 6 meter per second. And this is very, very less compared to the speed of light c. So our assumption kind of makes sense. Now in the third and last part, we have to find the potential difference the electron must be accelerated through in order to have this wavelength. Now we know that the potential difference, let's call it delta V, is equal to the change in kinetic energy, or delta K. So this is equal to kinetic energy final minus kinetic energy initial. Now, since the electron is starting from rest, the initial kinetic energy is basically zero. So the potential difference is just the final kinetic energy, which is equal to half m times v square. And v is the value we found over here. So this will be then half times 9.11 times 10 to the power minus 31 kg times 1.6 into 10 to the power 6 meter per second square. And also one thing to notice, this value will be in joules, and we want to find the potential difference in terms of electron volts or simply volts. So for that, I need to multiply it by a factor of 1.6 times 10 to the power minus 19 joules per electron volt, because 1 electron volt is basically this much joules. And doing all that, we get the potential difference to be around 7.43 electron volt. Let me box the momentum that we found as well.